Alright, today we're going to be talking about Boyle's law, and that has to do with two variables. It has to do with pressure, and it has to do with volume. So we're going to start talking about what each of them means to start with. So pressure, it's the force exerted by a gas per surface area of an object. So what that means is for a certain area that you have, you might have a square like this. So you know the surface area of this square. It's every time a molecule hits that, okay? That's going to be the force, okay? The force of hitting that area. So you can see in this balloon we've got a bunch of different molecules that are bouncing out into the inside of this balloon. So this would give you the pressure of the balloon. On the outside of the balloon, there are molecules that are still hitting into the outside of the balloon, okay? That would be the pressure of the atmosphere acting on the other side, okay? So there's pressure happening on both sides of the balloon, all right? So gas pressure is really the result, billions and billions and billions of rapidly moving, really fast particles, and they're simultaneously all hitting with an object, with that area. Okay, so there's a couple of different measurements that we use to talk about pressure. Atmospheric pressure, millimeters of mercury, torr and kilopascals are our most common. The standard unit for pressure when we're talking about scientists, what we use, the SI unit is pascals. Okay, but what we're going to use, these values are going to be our conversion factors if we need to convert between units of pressure. We're going to use 1 atm is our standard pressure, okay? 760 millimeters mercury, standard pressure, okay? So these are all your standard pressure values. It's easiest to remember it as 1 atm though. So that's your standard pressure. All right, let's talk about volume. Volume is the amount of space that an object occupies. So how much space does something take up? This is typically measured in liters for us, or milliliters. And you can remember that 1 liter is 1,000 milliliters. Okay, so that's a great unit conversion to use. And it's also important to know that 1 mole of gas, of any gas, at standard temperature and pressure, is going to occupy 22.4 liters of space. So you can use that as a unit conversion as well. 1 mole of gas is going to occupy 22.4 liters of space. All right, let's try some practice problems with Boyle's law. Okay, Boyle's law relates pressure and volume. Okay, they're actually inversely proportional, so that means that when pressure goes up, volume goes down. Or when volume goes up, pressure goes down. So they work as inverses, okay? They're inversely proportional, okay? They're inversely proportional. Pressure increases, volume decreases. Pressure decreases, volume increases. So this formula right here in the center, this is actually Boyle's law. And so what you basically are going to do, you're going to put your initial conditions here, which is your P1 and your V1, and then you're going to have one of these two as your final conditions. And you're going to use that to determine the fourth value. So you'll always get 3 out of the 4 values, and you just need to solve for the final either pressure or the final volume. Okay, so let's give 2 examples together. First example, gas occupies 4.31 liters at a pressure of 0.755 atms. What's the pressure if the volume decreases to 2.6 liters? So we're talking about a volume decrease. Pressure we're hoping is going to be increasing. So let's see if our math works out for us. So let's start by writing out Boyle's law. So P1 V1 equals P2 V2. Now we can go into our problem and circle our values. Well, I have an initial volume, that's the liters. I've got my initial pressure there. Okay, it says what is the pressure, so I know that that's what I'm looking for. And then I've got my second volume. Okay, so labeling right in the word question what your values are that you're given is very important. Okay, so now I can rewrite. So I have 0.755 atms as my pressure 1, and then my volume 1 is going to be 4.31 liters. Notice I'm making sure to include my units. And then what is the pressure? So I don't know what the pressure is. So P2 is what I'm looking for. And we're going to multiply that by V2, which is 2.6 0.60 liters. Okay, so you'll notice your liters will cancel out on both sides. All right, so what you're going to do is you're going to multiply these together, 0.755 times 4.31, and you're going to divide by 2.6 liters on both sides. 2.60 liters cancels out, and you should get an answer. Your liters will cancel out, and you're left with ATMs. Pressure 2 should be equal to 1.25 ATM. So try that on your calculator and make sure you get the same answer. All right, and that's it. That's the first Boyle's Law problem. All right, so we're going to start our second example. We're going to do this next problem. So 540 milliliters of a gas has a pressure of 180 millimeters of mercury. What is the volume of the gas at standard pressure? So just looking at this, it makes me a little nervous. I only have 2 numbers in there. I should have 3, right? I need 3 out of the 4 variables. But what I do know is it says standard pressure. So I know my standard pressure is either 1 ATM or 760 millimeters of mercury or 760 torr or 101.3 kilopascals. Okay, so in this case we're looking at millimeters of mercury, so I have to use the same unit. So I'm going to use this value. Okay, I would like you to memorize these 2 values. I'll give you kilopascals if you need it. All right, so what we're going to start by doing is writing our formula. P1V1 equals P2V2. I just established my pressure, my second pressure. My first pressure is right here. And then my first volume is right here. And this is in milliliters. You can leave it in milliliters for now, but if you'd like to, you can also change it to liters. We're going to be changing to liters in many of our other problems, so you can get practice with it. That would be 0.54 liters. You just have to divide by 1,000, okay? So my pressure is going to be 180 millimeters of mercury, Hg. And then I'm going to multiply it by my volume initially, is 540 milliliters. Okay, and what is that going to be equal to? My second pressure, which is what I don't know, that's what I'm looking for. Okay, times my volume too. So my second volume is going to be my standard. Oh, what is the volume? I do know my pressure. Just kidding. My pressure is 760 millimeters mercury, standard pressure. I'm looking for volume. My apologies on that. All right, times volume too. We're not sure what our volume is. All right, so what I'm going to do is I multiply my 180 millimeters of mercury times 540 milliliters, and then I'm going to divide by 760 millimeters of mercury on both sides. So you should get volume 2 equaling about 127.89. And what is the unit for volume? Well, right here, I'm starting with a volume of milliliters, so it's got to be the same. Milliliters is my volume. And that is it. All right, so that's it for Boyle's Law.